since I'm moving, I have my like sort of travel mic with me.
Uh-huh.
And for some stupid reason, I packed the stand and the pop filter, but not the mic. So I'm holding it in my hand. I hope it doesn't, I hope I can hold it for an hour.
I'm not laughing at you. I'm laughing at you.
Yeah.
Can you put this on video? We all want to watch.
Well, sure. Why not? There we go.
I like it.
How's
Kind of like a crooner. Or Frank Sinatra.
Start spreading the news.
Would you like to join the conversation with the iPhreaks and their guests? Want to support the show? We have a form that allows you to join the conversation and support the show at the same time. You can sign up at iPhreakshow.com/forum. Hey everybody, and welcome to episode 59 of the iPhreaks Show. This week on our panel we have Ben Sherman.
A severed foot is the ultimate stocking stuffer.
James Zuber.
Hello from Minneapolis.
Andrew Madsen.
Hi from Salt Lake City.
Pete Hodgson.
Hello from the West Coast.
I'm Charles Max Wood from DevChat.tv, and this week we have a special guest, and that is Carl Brown.
Hello from Austin, Texas.
Do you want to introduce yourself really quickly, Carl?
Sure. So I'm a iOS dev, mostly do contract stuff. The first app I shipped was the calorie tracker for Livestrong.com. So I've been doing a lot of health stuff. The last few months, I've been working on an app for a wearables company in town. They've got a watch that they're in the process of building that counts reps and sets at the gym. And I did a presentation last September on apps that talk to devices, which is what we're going to talk about today.
Very nice. When you say apps that talk to devices, we're talking Bluetooth?
Not necessarily, but lately that's become the standard. I guess a year ago, I was working on a device that had a Wi-Fi server built into it, and then we talked to it that way. Things like the AR Parrot drone, which is this quadcopter that the app talks to, that uses Wi-Fi. But Bluetooth Low Energy has become more and more popular lately.
I have a little experience with this, and it seems like in the olden days, really, unless you wanted to join Apple's Made for iPhone program, which is not really necessarily an easy thing to do, Wi-Fi was really your only option. Is that right?
Right. And the nice thing about Bluetooth Low Energy is that you don't necessarily have to have the whole Made for iPhone program. You don't have to go through if you want the Made for iPhone sticker on it, you do. But you can build a device and you can talk to it, or you can take a device off the shelf like a Sphero or a AR Parrot drone, and you can, the AR Parrot drone doesn't do Bluetooth, but you can take a Sphero and you can write your own app for it and put that in the store, which is really cool, and you don't have to go through the Made for iPhone program at all if you don't want to.
So if you're like a Raspberry Pi tinkerer, then you really don't have anything stopping you from talking to that.
Right, which is a very nice thing compared to the way Bluetooth used to happen.
So what are all the ways? I mean, there's Wi-Fi and Bluetooth that we've talked about. You can plug stuff into the Lightning adapter, I guess.
Right. And the old 30-pin adapter. But both of those require licensing and going through the Made for iPhone program. And then there's some stuff like Square that's gone through the headphone jack, the little credit card reader thing.
Oh, yep.
Those are pretty much the ways.
Yeah, I've always wondered what my credit card sounds like on Square.
I actually saw a Strange Loop talk where they played it back. The guy that was the lead engineer on the swiper did a whole talk about like how it works. It was really, really interesting.
Yeah, I was really surprised when it made the cha-ching sound.
But fundamentally, the stripe on a credit card is not really any different than a cassette tape, audio tape.
Yeah, it's just ones and zeros. It's a fairly standard format. I did a startup, 10 years ago that did debit cards. So it's a fairly standard kind of format. It's actually fairly low bandwidth. There aren't very many digits on it at all.
I saw a cool little product the other day that was a light meter that plugs into the headphone jack. Yeah.
I haven't seen that one.
Yeah. Called Lumo, I think. Lumo.
So what kinds of things or what kinds of applications do people have for devices?
Well, so recently, last week at WWDC, they were talking about HealthKit a lot. So there are a lot of things like Bluetooth chest straps. There was some Bluetooth blood pressure monitors where you could basically take data, get that into your phone, and then eventually in iOS 8, you'll be able to get that to providers and hospitals and do all kinds of neat stuff with it. There's also, like I said, the Sphero, which is if you haven't seen it, it's a little remote control ball that drives around and uses Bluetooth. And it's a lot of fun. And you can actually use it as an input device too. There are some apps that use it as a controller, which is kind of cool. There are some games that do use that. There's a thing called Dice Plus, which are actually like physical 6-sided dice that you roll. And then the Bluetooth will actually tell the iPad or the iPhone what you rolled. And so you can add that as a physical component to the game that you're writing.
That is a really cool idea.
I know. Why didn't I think of that?
Yeah.
And the really nice thing about writing apps that talk to devices is you segmented your market. So as an indie app developer who's trying to get noticed in the App Store, one of the things that you can do is you can write an app that supports one of these devices, knowing that at the point that someone actually buys one of those, like a Bluetooth heart strap, the first thing they're going to do is say, okay, let me go search the App Store for apps that support this heart strap I just bought. And now, instead of having to compete with all of the apps on the App Store, you're only having to compete with a very narrow set. And you know that the market that you're competing for is not every iPhone developer or every iPhone user in the world, but ones that had enough spare cash and were important and cared enough about their health to buy that specific heart strap, which is kind of useful from knowing what you can charge for your app.
Yeah, that's definitely interesting. And, I bet the average price point for that is much higher than your typical game.
It seems that the users will support a higher price point for that. If you really care about your health, then you're willing to pay more for those kinds of apps.
Do you want to get into some specifics about, how you communicate using, say Bluetooth to a device?
Sure. So there are a number of standard Bluetooth protocols. They're GATT is how they're referred to. The heart rate monitor is one of them. There's a battery one that lets you basically see from a particular device what the battery use of it is. There's a blood pressure one. There are a number that are standard kind of Bluetooth industry. Here are the standard protocols. There's another set of stuff that Apple does for like notifications. So if you have a Pebble or I have a Fossil MetaWatch. If you have one of those, then basically it can send push notifications directly to the watch. And in theory, you could send it to anything else that use that same protocol. So you could send it to the dashboard of your car or that kind of stuff if you wanted to be able to see notifications there. So that's an Apple kind of thing that's part of core Bluetooth. And then also in part of core Bluetooth is a thing where you can basically define your own characteristics. You can define your own attributes and you can define your own data protocol and packets between a device and a phone. And so that's what we're doing in the wearables world is basically, so the company I'm working with, we're sending accelerometer data. And so we're having to make up our own protocol between the watch and the phone to be able to move data back and forth. And that's all from a developer standpoint, inside the core Bluetooth protocols.
The way I understand it with Bluetooth Low Energy is it's not like with Bluetooth, it felt like it was more like a two-way stream of stuff, but with Bluetooth Low Energy, the model is more that you're kind of setting values somewhere and then the thing that's listening to you kind of notices that the values change. Is that right?
Yeah. So the normal, I don't know if normal is the right word, but the way that we usually do it is there's and I'm going to mess up the class name. So basically a peripheral did update value for characteristic. And so basically I register for a callback and say, okay, anytime this particular characteristic on the watch changes, then I want this block to run, this notification to run. And then I get this callback from core Bluetooth that says, hey, there's a new value for this heart rate thing, or there's a new value for this accelerometer thing. And then I have my code right there that does whatever it is that I need to do, store that to disk, send it off to a web server or whatever happens from there.
Or make the numbers lower so that I don't feel so unhealthy.
That's in the presentation layer.
You mentioned accelerometer data. That's presumably that in theory can be changing super fast. Like how many of these characteristic change events can you get in a second, or how frequently can you get? So
you can run 60 hertz, which is basically the frame rate. You might be able to run a little faster than that, but if you get too much faster than that, you can go a little bit faster than that, I think. But if you get too much faster than that, then you'll start to back up because you're literally not going to be able to move the data between the watch and the phone as fast as you can collect it. And then it'll basically just start queuing up and queuing up. So in my experience, if you're sending 20 byte packets, which is the default, you can run about 60 hertz. That's about as fast as you can get. So 60 packets a second.
Gotcha. Is there more battery drain the more things are changing, or is it kind of a constant?
So the more packets you send, the more battery drain there is. It's important, though, there's a session on low energy at WWDC last week. It's very important that to the extent that you send as much data as you can altogether and then stop to let the phone go back to sleep. So if you're like waking up once a second and sending something and then going back to sleep and waking up the connection once a second and going back to sleep as the watch, the phone basically never gets a chance to go to sleep, and so it never has a chance to turn the battery off, or not off, but to reduce the battery usage. So that will really drain the phone quickly over time. But if you basically say, okay, I'm going to queue up everything that I need to send, and I'm going to send it all in one burst, so the phone only has to pay attention for that short period of time, that's pretty good for battery on the phone and on the watch, because it's expensive when you're talking about tiny little batteries.
So you just aggregate the data to a certain degree on the watch and then send it all at once.
Right.
In Apple, are big fans of doing that in other places, right? Like only waking up the network every now and then to poll for new GPS locations or something like that.
Right. Powering on the radio is always more expensive. And from what I understand, powering on the cell radio is actually really expensive. So the time it's really important is if you're doing a bunch of bandwidths or doing a bunch of server stuff, talking over, 3G or LTE or that kind of stuff. You really want to batch those and then wait. But the cool thing is the new NS download tasks and NS upload tasks. You can just basically say, okay, so here are my tasks. Here's how often they need to happen. And then it'll kind of queue them so that when all of the different, this is in iOS 7, but when all of the different things on the phone are ready, it'll light it up, turn all of the apps that need to send something on, let all of them send, and then turn it back off. So that saves a lot of battery life.
So if you have a device that has custom data, how would you specify in your application like what the data is? Is it like an NS dictionary? Is it C-struct? How does it happen?
It actually comes across as an NS data bytes. So you get from the value did update for characteristic, you get an NS data structure, and in that structure there's bytes, and those bytes are in network byte order. And so basically you have to do this, God help us, you have to go actually down to C, and you actually have to parse out all the stupid little integers or strings or whatever it is that you've got, turn that into something you can actually use in Objective-C or Swift maybe, and then you can take that and then you can run with it from there. But when you actually get it off the wire, it's in raw bytes.
In some sense, it seems like that's what you want, though, right? If you're doing something completely custom, you want to be able to send any data you could come up with.
Putting a firmware development hat on, which is not something I do all the time, but I talk to the firmware guys at the companies I'm working with. Putting the firmware developer hat on, I would certainly not want to, in a tiny little watch with, 50K of memory or something, I would not want to try to parse something out of an NS object structure. Right. That would be just a waste. And I wouldn't want to send pointless ISA pointers across the network because it's not of any value once you get on the embedded C device that doesn't have Objective-C. So going to, okay, here are exactly the bytes that we need to send saves the most bandwidth, and it makes less work for the people on the other side that have to decode it because they have a much harder job than we do because we've got a lot more high-level structures and libraries to use.
And then you base 64 encode that in a string and wrap it in a soap envelope, right?
No. And then you divide it up into 100 different packets to handle the overhead, and you send them one at a time.
WS low energy.
Oh, God. It probably exists.
So it sounds like, in this case, what you're talking about, if you create a different version of your protocol of the data, or if any of the types change, then you have to manage the versions. Is that correct?
Correct. So there's a standard Bluetooth protocol for software version and hardware version, as well as like device type. So you can ask, hey, you're a watch. What brand are you? What serial number are you? What model number are you? But there's also software version and hardware version and firmware version of the actual device itself. So as part of the process, when the phone is connecting to the watch or the Sphero or the whatever, you say, okay, so what firmware version do you have? Okay. For that firmware version, I know what protocol you've got. In the event that you've got more than one protocol, you have to switch back and forth between. And that way the device, which has a much harder time from a programming standpoint, only has to worry about its protocol. And then the phone can say, okay, so for this particular firmware version, this is the protocol I need to use. And for this particular firmware version, I need to use this one over here.
Ah, very nice. I did this type of work very early on, like in the 90s, doing like embedded work. And we'd create a structure, and we'd add something, and we ended up doing things like making the structures bigger than they had to be in case we needed it in the future. And that's probably not the right way, but this is a little smarter way of doing it.
Well, I still end up with some of my protocols, and I have 3 zeros on the end of the packet that are reserved for future use, just in case I end up needing them at some point.
Okay.
Yeah, I was going to say, I always remember that from C programming. There's like the 5 things you need, and then a chunk in the middle that's like reserved for future use, and then a chunk at the end that's like private, don't touch. Like, used for some internal thing. Don't worry your pretty little head about that.
Well, I spent some time, long time ago when I was in college as a network admin debugger type, fighting with Cisco router stuff. So I've spent a lot of time looking at sniffers and TCP/IP protocol headers. And so I kind of took my cue from that and said, if those guys have managed to build that protocol and we're still running it, I don't know how many decades later, then probably they had some idea. And so maybe it wouldn't be a bad idea to put a bit field in there that I could throw stuff in. And actually, a lot of the core Bluetooth protocols have something like that. So in the heart rate monitor, for example, there's a 16-bit version of the heart rate, and there's an 8-bit version. And there's a bit field that actually tells you whether the next set of bytes are going to be a 1 byte or a 2 byte thing, just in case there's somebody who has a heart rate more than 256.
When you're talking back to the device, do you talk back in the same way? Use a similar protocol?
Yeah, that's a good question, right? Because it's this whole like central versus peripheral thing.
Right. So a lot of times what you do, you're not sending a lot of data, right? So usually the data is pretty much going one way. It's going from the device to the phone. And so in the phone, instead of saying, hey, I'm going to subscribe this thing, you basically just say, I'm going to write this particular characteristic. And then when you write it, the watch gets one particular value that says, hey, there's a value for this, and it doesn't have to do the subscription and all of that kind of stuff. So typically what ends up happening is on the phone side, you're subscribing to a characteristic that the watch just repeats over and over. And on the watch side, you're just waiting for a value to get written to you.
But the model is kind of fundamentally, it's not like peer-to-peer, like I send you stuff, you send me stuff. There's these two distinct roles, right? Where the peripheral, which is like the watch or the device, and it's publishing characteristics. And then there's the central, which is like the phone in this case for us normally. And that it's generally, it doesn't serve up characteristics. Is that right? I'm very like half understanding of this stuff. So sorry if I'm asking stupid.
That's a fair approximation. So there's the central that the phone normally uses. Well, so as a general rule in the Bluetooth world, it's all implemented in a firmware thing, in a chip and that kind of stuff. The interesting thing there's actually a really good, it's called the BTLE Central Peripheral Transfer Sample Code from Apple. And you have to have two devices, but you basically put your iPod Touch, you make it transmit, and you have your iPhone and you make it receive. And then you can actually watch the protocol as it moves from one to the other, and you can see the reading and the writing on both sides. It's actually been really, really helpful.
Oh, cool. So if you wanted like full on two-way communication as like peer-to-peer rather than kind of client-server style communication between, say, two phones, is Bluetooth Low Energy just not? Are you going to be fighting against the model if you're trying to use Bluetooth Low Energy?
You probably could. I mean, my guess is if you're trying to do full-blown two-way stuff, you're probably going to run into, at least my guess is you're probably going to run into bandwidth limitations before you run into much else. Bluetooth Low Energy is a fairly low bandwidth kind of thing. It's really not designed for lots of, back and forth. And so what it might be better to do is go into the Bluetooth 2, which is the full-blown peering thing like you're used to with like Bluetooth headsets and that kind of stuff. And then you can actually get a stream both ways and you can have lots of back and forth. So it kind of depends on what you're trying to do. But so there is some like two-way stuff in Bluetooth LE, but it's really not designed for that. It's really designed for I'm talking to a peripheral and the peripheral has some stuff for me and I'm going to go grab it, or occasionally I'm going to tell the peripheral something.
So with Bluetooth 2 on iOS, at least, you have to be in the Made for iPhone program. Is that still true? It used to be true, but I haven't really heard lately if they changed things.
I'm not a lawyer and I don't play one on TV, but I'm pretty sure that at some point I've paired a headset with my phone that didn't have the Made for iPhone seal on it, given the number of headsets that I've gone through over the years.
Well, so sure, yeah. I'm not talking about a headset, which I think is just a standard thing for phones, but I'm saying if you wanted to develop your own peripheral and your own app that did custom non-audio profile, but just custom data, I think that still requires Made for iPhone.
As I remember, I don't do Bluetooth 2 very much anymore, but as I remember, there's a standard like serial protocol that you can move stuff back and forth between, and I don't know that you would have to have Made for iPhone for that, but I haven't looked at the requirements lately.
It's kind of like, because I was looking into this the other day for some ridiculous side project that I don't even want to explain. And I think there is, like Bluetooth Low Energy has these kind of standard characteristic sets. In Bluetooth, there's these kind of standard protocols, and one of them is like essentially just a serial port, and it just has a standard way of kind of bridging between what looks like a serial port to software and what's actually on the wire is whatever magical Bluetooth packets need to be done.
Yeah, so actually, fun fact on OS X, if your Mac has Bluetooth, which they all do now, of course, the Bluetooth hardware shows up as a serial port. So if you fire up an app that just knows how to do serial, it will see those Bluetooth ports and it can't tell that they're anything other than a regular serial port.
Well, that's interesting.
Yeah.
But that's on the Mac where we can do anything.
That's pretty tricky.
Earlier on, you were saying that there's some, like certain classes of devices that have kind of like a standard Bluetooth working group, or whatever it's called, assigned like protocol. So like heart rate monitors or, I don't know, temperature gauges or whatever. In the past, when I hear about that kind of stuff, I'm always a bit suspicious that they'll actually be able to interact with each other correctly. Like if I write software for one heart monitor, that it'll actually, it's supposed to all be the same, but it turns out that with this manufacturer's heart rate monitor, they encode it in beats per second, and this manufacturer, they misinterpreted the standard and did it a different way. Have you heard of cases where people still have to have software that only works with certain brands' implementations or whatever?
No. I guess the good thing is those protocols are relatively simple. Now, what happens a lot is a lot of those protocols have a bunch of optional things. So like, for example, with the heart rate monitor, there's an optional thing where you can say, I'm attached to the wrist, or I'm attached to the ankle, or I'm attached to the chest, or I'm attached to the ear, or whatever. And there are other optional protocols that say, hey, and this is my current battery life and that kind of stuff. And so a lot of the manufacturers don't implement the optional parts of the protocol. But if you just want a raw, here's a heartbeats per minute number off of this device, there are basically two ways to do it. You can get the 8-bit number and you can get the 16-bit number, and you can look at this particular bit in the header and it'll tell you which one of those you're going to pull. So that is a fairly simple kind of thing. And then it can get more complicated after there from a manufacturer standpoint. But if all you want's the simple thing, then I haven't run into one yet that didn't behave for me.
Gotcha. I guess the only thing I could see happening is you write your app using like the swanky fancy pants heart rate monitor that implements all the optional stuff, and then you never tested it on the cheapo heart rate monitor that doesn't implement the thing that you're expecting, and then you have some stupid bug where you're like looking for a value that doesn't exist or something.
Yeah, or you end up with a giant piece of the UI that's got a big 0 there for battery life or something.
Yeah.
Because the device doesn't support it and you didn't think to conditionally check to see if you needed to put that piece of UI there or not.
Right. And all the app reviews just say, sucks, 0 for battery life, 0 stars for you.
Right.
So you were talking a little bit about like the health kit and stuff. Is that actually a new library in iOS? I haven't had a lot of time to spend paying attention to WWDC yet.
So HealthKit is a new framework in iOS 8, and it lets you take a number of, or will in September, or whenever they release it, lets you take a number of different standard Bluetooth protocols or GATs that correspond to health data, like heart rate monitor, like blood pressure, like blood glucose, for diabetic meters that have Bluetooth LE in them. And then it lets you take that and put it into this health kit in a standard way. And then the other thing that's kind of cool is from there, another app can, assuming that you give it permission, get access to that data. So for example, if you had a diet app that was basically tracking you were typing in the food that you eat, well, that diet app could now also get information to the number of calories that you burned with your Fitbit. And so you wouldn't have to input that information twice. So it's kind of a hub for the way that all of the different apps that you might have on your phone that deal with health data can talk to each other and share things in a well-defined protocol.
That's really, really interesting. I'm diabetic, so I'm really curious about where this can go and how it can help me with my particular issues. So.
Well, they had folks, they were talking to people there from like the Mayo Clinic. They had some other records-based things and doctor stuff, and they're talking about potentially having the whole thing set up so that, your glucose monitor or your insulin pump can talk to your phone can talk to the internet, or your insulin pump can talk to Bluetooth LE that talks to HealthKit, which can then talk to an app that also talks to HealthKit that can dump that directly to your doctor's office, and they can monitor things and all that kind of stuff. So, there are privacy implications of that, and Apple seems to be being very careful about that. But it's an interesting world, especially for those of us. I'm not diabetic, but I'm asthmatic, and there isn't really a corresponding Bluetooth LE thing for that. But I can imagine, a peak respirometer or something that would be the same kind of thing, which would be cool.
Yeah, my take on it was that there were two uses for it. One, you could have devices that stuff data into it, but you could also have specialized apps that take the data and render it in new and useful ways. And one of those might be to communicate with your doctor's office. Another might just be to help you discover patterns that help you live your life better or whatever.
Right.
Sleep was one of the ones that I found to be interesting, because each data point in HealthKit is not just one number, right? It's like a timestamp plus some value or set of values. So for the sleep one, it's like, what time did I go to bed? What time did I actually fall asleep? What time did I wake up? And what time did I actually get up? And so it's a quadruplet of data that you can graph. And once you have the data in there, any number of apps can use that data in interesting ways.
And then there's a metadata dictionary you can stick on that too, that if apps agree on what they're going to put in that metadata, there's a whole other sharing service that can happen from there.
Interesting. I was browsing around in the iOS 8 simulator. You can play around with HealthKit or the health.app. And there's a setting in there. I probably shouldn't giggle because it's not funny, but there was one I saw that was number of times fallen. So you could imagine just like a little counter It would be very sort of inconvenient to go through health.app to enter in data. It seems like that's just sort of a way to let you see it and enter it in initially until like apps start creating specialized interfaces, or better yet, having meters that interact with the real world.
Right. It very much seems to be we know that all these devices exist. And so we're basically trying to make a way for all of them to talk together and for the user to not have to have an app for every one of them. And then once you go past that, the next thing that they announced, which was kind of a similar thing, is HomeKit, where you can write apps that can talk to, your thermostat, your garage door, your lights in your house, all that, your curtains, if you've got that kind of thing, all in a very prescribed kind of way. You can make zones and all that kind of stuff. So that's a whole nother set of apps that you can write that can talk to peripherals, that can really interact with the real world. Although in that particular program, I think we're going to have to wait. I don't know how many exist right now, but we're going to have to wait for the, HomeKit enabled light bulbs and all that kind of stuff to start showing up on the market. But
yeah, I'm sure there'll be some adapters. I'm certain companies like SmartThings will be all over it. Because they have sort of a competing ecosystem of products, and they would probably only serve to help them to have some tight integration with HomeKit, because it's certainly piquing interest around here among non-techie friends.
It's really interesting, this kind of competing efforts to kind of own if I'm going to play buzzword bingo, the Internet of Things, like the gap in between the Internet of Things, right? Like I want to be the person that enables your fridge to talk to your grocery store or whatever. Did they make, with the HomeKit announcements, was it just about iOS, or did they also talk about like plugging it into Apple TV or OS X?
I don't think they made any specific announcements about that, but we were discussing it internally because we have a product that will fit in to this quite well. It's called the refrigerator to the grocery store. just kidding. So anyway, we're just, wondering of all of the sensors and triggers and actions that you could take from HomeKit devices. Do you have to be home to do them?
Right.
Because presumably you would have to be on the same Wi-Fi network for you to interact with them. But if they are connected to iCloud in some way, like for instance, an Apple TV that pretty much everybody who's interested in this stuff could afford, if not already own multiple versions of it. Seems like Apple TV is sort of in a unique place to provide that hub. Whereas like a SmartThings or a Philips Hue, they all have hubs that allow it to talk to the network, allow these devices to talk to the network. So if there's something like that, then there's got to be some sort of persistent device in the home. And Apple TV seems like the perfect thing to do it. Or an Airport Extreme, which a lot of people have as well.
Yeah, a lot of the things that I see around this are, quite a few of them talk about kind of the home entertainment center or something like that being the obvious place to stick kind of the integration where, the light bulb can talk to I don't know, not to the thermostat maybe, but your light switches talking to a light bulb makes sense that you would just wire them kind of up directly, as it were. And they're probably manufactured by the same people. But if you want the lights to kind of brighten, I don't know, when your cat comes through the door and you want your cat flap is using a different manufacturer, then you need like a single place where all this stuff kind of comes together and then goes out. And it seems like a entertainment center or something like that is an obvious place.
Right, so,
that's a startup idea that someone is very welcome to take, by the way, the internet-enabled cat.
I think it's interesting, though, that we're talking about. I mean, a lot of the home automation stuff, you just, it's a peripheral that you control through your Wi-Fi. But the idea of controlling it through the internet, through a device, that talks to everything else, I think that's really, really interesting. So effectively, then, your peripheral connector is the internet.
Yeah, so I wanted to ask about that. That gets into actually a different paradigm than we've talked about, which is you don't actually communicate locally. You're communicating over the internet with a connected device, and I think that's getting pretty important. So do you know anything about that?
I haven't dug into that particular thing. As I remember in the presentation, they were talking about, if nothing else, as you drive up to the house, your garage door opener would open your garage door by itself and it would turn the house on and all that kind of stuff. I remember something about thermostat changing based on where you physically are. So like geolocation kind of stuff. So that might be actually when you leave the house, or it might be, knowing, oh, okay, he's staying at the office late kind of thing. I'm not exactly sure how that works. I haven't dug into that much, how that works when you're not physically in the house.
I have a Nest. I think the way it's advertised, people think it probably does this, but it actually does not use your phone remotely to figure out if you're home. It just has internal sensors that detect you walking around in front of it, and if you don't walk around in front of it for so long, then it assumes you must have left the house. But I think I saw just yesterday.
That wouldn't work for cats because they lie still for a long period of time.
Yeah, right. Well, and they mentioned somewhere in the manual that if you have pets, particularly
Not for cats.
pets, I saw that Honeywell announced a new thermostat that's sort of a competitor to the Nest, maybe just yesterday, that does use an iOS or Android app, and I think they're using the geofencing APIs to actually detect, you're coming home and you're 10 minutes away, so they'll turn the heat on for you so the house is warm by the time you get there, that kind of thing. So I think there's a lot of possibility around that, but we're just starting to see it happen.
And if it's not set up to happen now, then it will by the time we get to, iOS 9 or iOS 10 or something. It's pretty much inevitable at this point, I think.
Now I'm distracted looking at the Honeywell thermostat. It just sounds like such a Me Too product. I kind of imagined it like a regular, like cheesy plastic thermostat with like a, but like round or something. I don't know.
And then another set of products is like home security cameras. So there are apps. These are outside of HomeKit, and I don't know if they're exactly how they would work with HomeKit, but they're basically apps you can get where you set up your webcams in your house, and then you have your app, and it talks to, I guess, a web server either in your house or somewhere else, and you can actually see the streams from the cameras in your house on your phone. And actually, some of the security companies in town, or I think the cable company Time Warner here, where I live in Austin, has that kind of service where you can basically get an app on your phone that can see the various cameras that you've got in your house. So it's converging fairly quickly.
Yeah, so the Dropcam, I think, is the biggest of those. But there are a bunch of companies making those kind of cameras that they seem really cool.
So are there any other gizmos that you talked to? I want to go back a little bit to like the Spheros and the quadcopters and stuff like that, which are kind of interesting peripherals. Are there any tricks to those? I mean, do they just come with an app that works, and can you write your own apps? I know you can for the Sphero to some degree, but...
Well, so a lot of them have basically developer programs. So like the dice I was talking about, the physical dice, they have a developer program. You sign up. It's, I don't know, single digit $100 kind of thing, maybe less now. And then you basically get the SDK from them. You use that to talk to their device. I assume that encapsulates whatever protocol they use to go from the dice to the phone. And then you write your app using their libraries inside your app, and then you publish it, and you have use this with your Dice Plus kind of thing. You send them a link to your app. They feature it on their site. And so it's also a nice kind of marketing thing for you, for people that already have those things or are looking for an app for it. So that seems to be kind of, I don't know that everybody's doing it that way, but when you've got products like that, some of them actually, like the AR Parrot drone, the Wi-Fi quadcopter, they open source their library that lets you talk to their quadcopter. But a lot of them have a developer program that you sign up for, and you get the SDK that way. And then you can use that to write, I presume, whatever apps you want.
Yeah, the other question that I have is, I've heard about apps where, like a Scrabble game, for example, so you have an iPad, then you have a bunch of iPhones or iPod Touches or whatever around them. And so you can see your tiles on your phone, and then you can see the board on the iPad. So I'm a little curious. Do you know much about an iPhone as a peripheral?
There are a couple ways you can do that. There's this multi-peer connectivity thing, and there's a multi-peer chat sample app that you can get from Apple that will let you play with that. But you can basically create a mesh network, not necessarily a mesh, but a topology where you hook apps together, and then you can transfer data back and forth, and you could build a board that way. And it's actually kind of a cool technology, because you can actually get to the point where you've got a group of people that are playing, and each one is in range of at least one other person, but the two people on the ends can't actually see each other, but the packets get relayed all the way through all the other phones. So you could do it that way. You could do some kind of a Wi-Fi client server thing if everybody was on the same Wi-Fi network using Bonjour and the standard Apple networking protocols. Or sure, you could come up with some other things. Kind of random. My daughter actually has a little Furby, one of the newer ones, and I have discovered, actually uses a really high-pitched sound you can barely hear to talk to the iPad app that talks to it.
Oh, weird.
So the app actually listens on the microphone, and the Furby actually uses a really, really high-pitched thing to talk to it so that it can tell that it's hungry or that it's being petted or whatever, which is kind of interesting. So there are all kinds of different little tricks that people come up with for...
Yeah, I've seen that as well, where it's like outside the range of human hearing, so none of us care. Maybe dogs get annoyed by it, but
I was going to say, you have a dog?
Yeah.
No, I've got two cats, and they don't seem to mind, but I don't know about a dog.
It's pretty accurate too. I was surprised. I saw a demo of an app at CocoConf, and it basically would was something around music, and I can't remember what it was. Basically, they would communicate with people around you who have similar interests, and so it was transmitting your interest in music to other people who had the app. They were sort of in prototype mode, but the biggest drawback is that you had to leave the app running, and it had that little red recording thing pulsating all the time, which seemed like a huge non-starter. But it was definitely an interesting proof of concept. I was surprised that it worked.
Interesting. All right, well, I know we have a hard stop here in about 10 minutes for one of our panelists, so let's go ahead and do the picks. James, do you want to start with the picks?
Sure. I've got this problem every day. I don't know if I want tikka masala or if I want a sandwich. Pete, I know you have this problem every day too.
I do.
Yeah. He's emailing me. He's like, James, what should I do? I'm like, Pete, just make a choice. But you don't have to choose anymore because you don't have to choose between tikka masala and a sandwich. You can have a naan-wich, which is tikka masala or whatever, punched in a naan. It's frozen in the frozen section. They're actually really good. So I'm a big fan. So I'm going to make my pick as naan-wich.
Ooh, that sounds really good.
It does sound good. It's lunchtime, too.
I know. Terrible. All right, Andrew, what are your picks?
I've got a few picks today. So the first one is along the lines of they're actually mostly along the lines of what we've talked about. There's a company called Red Park that makes lightning to serial cables, and you can use these without being in the Made for iPhone program. They've got the certification for this device. You cannot use it in an app that you put on the App Store, but this can still be really useful because using RS-232 or Serial is really still kind of the easiest way, especially on the hardware side, to just get up and running to talk. The Serial is super simple, a lot easier than trying to set up your own Bluetooth stack or whatever. So even just during prototyping phase, this can be really useful. And they've got several different versions for both Lightning and 30-pin connector, and they have an SDK that you use to make communicating with them quite easy. And then second pick is along those lines. I actually have a Objective-C library that's open source called ORS Serial Port. And this is for the Mac, not iOS. But again, when you're doing hardware development or prototyping, it's nice sometimes to be able to write an app, just a quick app that will talk over serial to your hardware. And it's basically an Objective-C wrapper for all the low-level C, POSIX, and IOKit functions for doing serial communication. So it makes all that a lot easier. And then lastly is a little product called the Electric Imp. And it looks like an SD card, but it's not actually an SD card. It just has the same form factor. And it's got built-in Wi-Fi. And then they've done all of the back end for you. So you basically can make a device that takes one of these imps that plugs in. It's got a microcontroller in it and Wi-Fi. And it's even got, they've already done all of the setup stuff. So if you want to make it so your iOS app can set the whole thing up and connect it to Wi-Fi, that's all super easy. And then they have the whole backend running on the web. So when you connect the thing to the internet, you just get a REST endpoint that represents that device. And it's super, super easy to communicate with over the internet. So these things are pretty cool, and you can buy a developer kit for them quite cheaply. I can't really remember how much they are now, but like less than $50. So that's the Electric Imp, and those are my picks.
Awesome. Ben, what are your picks?
Let's see. I was in San Francisco recently, so I went to mostly the usual spots. And I also found Pete's previous pick, 21st Amendment Brew for Your Die, which was delicious. What else did I do? I went to a place called McKellar Bar, and they had quite an impressive beer selection. I like Imperial Stouts, and they had probably 8 or 9 of them. One was upwards of 20% alcohol by volume. Yeah, and that was already a rough morning for me, so I skipped that one and went for a more middle of the road beer. But it was good. Definitely a good place to check out McKellar Bar. And I've been playing a new game from Mika Mobile called Battleheart Legacy. If you like Diablo style RPGs, action RPGs, you're gonna love this game. It's $5. It's a universal app. And I probably have like 10 hours playtime already in this game. So it's totally worth the $5. Anyway, that's really, really, really good game. So I will post the link to those in the show notes. And I got to hang out with James, so I'll pick James.
Thank you.
Aww.
So nice. Yeah, where was Pete? Pete was just kind of tweeting at us away saying you should hang out in the mission, you bunch of corporate sellouts. I never didn't see Pete. I got to meet Ben, though, so it was a good time.
Yeah, I was bummed I didn't get to meet you guys. I was in 500 hours of meetings, and then I was in Atlanta for like a company thing. So, yeah, next year.
Nice. What are your picks, Pete?
This is an oldie and one that we've already picked. A bunch of people have picked before, but I'm going to pick it now. Reactive Cocoa. So I've been playing with this. Had a long flight to Atlanta and back from Atlanta, so I was messing around with Reactive Cocoa, and it's really cool. I really like the paradigm, the functional reactive paradigm, even though apparently the guy that invented the term thinks that things like Reactive Cocoa aren't actually functional reactive, but whatever. So yeah, if you haven't played with it, yet another motivation to go play with it. My second pick is something really silly. It's called Count.io. It's a cloud-based counting service. It's kind of, that's it. That's what it does. I can't decide whether it's useful or just totally ridiculous. It's probably web scale, and it might be useful if you've got a connected device and you want to count something. I don't know. You don't have to build a backend. It's counting as a service. And my last pick is, yeah, really.
It sounds like the definition of a microservice. Maybe we need another one that does like adding two numbers together as a service.
Or like floating point math or something. I don't know. My last pick is a beer. It's Stone Go-To IPA. Stone do lots of big, heavy beers, lots of big IPAs. This is a session IPA that still tastes like an IPA. So it's probably, I don't know, like 4 or 5% alcohol. But let's have a look. 4.5% alcohol, but 65 IBUs, guys. 65. That's pretty high considering the alcohol. So yeah, it's good session beer. Tastes a lot like hops, but you can have more than a couple. More than that 20% stout, anyway. And that's my picks.
Very cool. I've got a couple of books that I've read lately. One of them is called The Miracle Morning by Hal Elrod. I heard about it on Entrepreneur on Fire. He actually interviewed Hal. And so the idea is that you get up early, everybody groan, and you go through a couple of different things to start off your day. And so I did it on Monday, and then I wound up losing most of the day to a tension headache, and I just wasn't feeling well at all last night and then early this morning. So I didn't do it this morning, but I'm going to get back on it tomorrow. But it really did feel good until my headache came on. Just being up and going through that stuff and, really kind of starting the day off right. So I'm going to highly recommend it. I really like it so far, and I'll probably report in after a few weeks and let folks know how it's still going. The other one is the Steve Jobs biography. I forget who the author is, but anyway.
Walter Isaacson.
Yeah. That's the one. So anyway, I'm enjoying that as well. It's just really interesting to see how all of this stuff came about and, just kind of the personality and the story behind Steve Jobs and Apple. So anyway, those are my picks. Carl, what are your picks?
There's a TI, they call it a sensor tag. It's a little $25 Bluetooth LE sensor that comes with the code that you can use to run it on iOS that has a accelerometer and a temperature sensor and a bunch of stuff in it. And it's a really handy little thing if you want to play with Bluetooth and sensors and peripherals and that kind of stuff. It's almost indestructible. You can throw it and bounce it off the wall. And then I have a couple of books, Halting State by Charles Stross, which is a near future science fiction thing in which everybody walks around with glasses that talk to their phones all the time, which is kind of an interesting thing of, where the peripheral stuff might be going in the future. And then a book called All You Need Is Kill by Hiroshi Sakurazaka, assuming I got that anywhere close to right, which is the novel that the new Tom Cruise Edge of Tomorrow movie is based on. And I have read the novel and seen the movie, and I actually like the novel better, so I'm going to recommend it. And then one piece of software that surprisingly I haven't seen in your picks yet, but I use all the time, is called Caffeine. And it's a little thing that sits in the menu bar of your Mac that prevents your Mac from going to sleep. And so I use it a lot for things like conference calls when I'm presenting at a conference, that kind of stuff. It probably gets used for me every other day, if nothing else. So I will put a link to all those in the show notes.
I use that all the time. It's got permanent space in my menu bar for that reason.
Yeah, me too.
And another thing that I think macOS 10's pretty good about not putting your machine to sleep when it's actually doing something. But when I do file uploads in the terminal, it doesn't seem to have that same protection. So the machine will just go to sleep while that's happening. And maybe it's just the screen. Maybe I'm just being paranoid, but I always keep the screen on to make sure I don't interrupt a large, perhaps screencast upload that I happen to do every week. So anyway.
Fun fact, there is actually a Caffeine command line app that ships with OS X.
Indeed. Yeah. I guess not by the same people, right? It's an Apple open source utility, right?
Yeah, but you can write a little script that will wrap your activity in that caffeine thing, and it will keep the computer open as long as that process is running.
You know, I knew about this and just never plugged the two ideas together.
Automate your life, Ben. Automate your life.
That's what you're here for, Pete.
Yeah, you're welcome.
All right. Well, let's go ahead and wrap up the show. Thanks for coming, Carl. Really appreciate you taking the time.
Thanks for having me. I appreciate it.
Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.